Cool. Ah, Jan,
Wolfing,
how are you?
good.
Good to see you. You've been busy these days. Do you have a moment to chat?
Let's do it.
Oh, great. I'm here super excited to see that the Tritium Milestone has been reached. Congratulations. It's the first milestone actually from the new roadmap that was released last week. And this is the first milestone in the Chain Fusion stream of work. And I'd love to get into the details of Tritium a bit, but if you could first give us like a bit of an introduction about Chain Fusion, I think it would be great to get some clarity on what has been going on, what's the big picture, and then we get into the details a bit.
Of course, my pleasure. So Chain Fusion is all about like all the other blockchains that are out there besides ICP and how we can make the nice properties of ICP, such like HTTP outcalls or Threshold ECDSA, these kind of things available to all these other blockchains. And so at the end of the day, the goal here is that like a smart contract on ICP can like talk to all these other blockchains, interact with all these other blockchains. So like one place, like make ICP one place where all these other chains are fused together in one place. So we can like have fun on ICP with all these other pieces.
Very cool. Yeah, it sounds great. And I think there's a lot of conversation at the moment about this multi-chain world or whether there should be like one ultimate blockchain to rule them all. But I think at least with Chain Fusion, we kind of believe that there's like merit and value in different blockchains, and it's useful to be able to communicate with them. And so this is why we kind of embark on this Chain Fusion journey, I feel at least. Maybe it's a controversial opinion, maybe not everybody agrees, but maybe one thing that I find interesting about Chain Fusion is, so maybe some people know about chain key cryptography. So this was like one of the big innovations of ICP. Everybody knows about it. And so one of the questions we get asked, or at least I see a lot, is Chain Fusion just chain key signatures now, or is it something more?
In my mind, it's much more. As you said, right? There's all these other blockchains out there, and each one of them has like their own properties, their own merits, their own advantages. I mean, start with Bitcoin, right? Like the digital gold, it's out there, like a lot of value stored there, but it doesn't really have like much of smart contracts. And it's like when we were building ICP, it's just like around launch, we're thinking, well, could we somehow like make use of Bitcoin instead of cool people like Bitcoin, right? And so we're thinking, okay, so what if like an ICP smart contract could also like own Bitcoin itself, right? And then you think, well, we have like a distributed system already, right? Like an ICP blockchain, like the subnet is like a distributed system, has threshold signatures, right? And if you want to own Bitcoin as a smart contract, if you have access to the functionality of threshold signatures, you can actually receive Bitcoin, you can sign Bitcoin transaction, right? So as a smart contract with threshold signatures, you can totally own Bitcoin or ETH and like any other crypto, really, if you have the right signature scheme, of course. But that by itself is not enough, right? I mean, if I have like an ICP smart contract that can own Bitcoin, but doesn't notice when it actually has received Bitcoin, or it can't spend it, right? So what you need more is you need to read and write to these other blockchains as well, right? So if you want to interact with like Ethereum or Bitcoin or like any other blockchain, really, you need to be able to read and write from those. So writing means, so I need to be able to sign transactions, right? That's where the threshold crypto comes into it. But equally important, maybe even more important, is the reading. So I want to be able to react to events like Ethereum events. I want to be able to react if I receive some Bitcoin. Maybe I want to sell some Bitcoin if some Ethereum event happens, or even sell Bitcoin or ETH or like any other coin, depending on some price they get elsewhere, right? Like somewhere on like a centralized exchange. So I want to also like interact with the rest of the world, right? And so in a trusted way, right? I don't want to have like a single source of truth here. Yeah, and so that's like why, apart from chain key signatures, you also need like a trustworthy, like a reliable, trustworthy way to read from the rest of the world, right? And so that's why, like for Bitcoin, we've integrated in the Bitcoin with the Bitcoin network. So ICP subnodes and ICP subnets are actually also like running clients of the Bitcoin protocol, getting all the blocks there, running consensus over blocks, make at least the UTXO set available to smart contracts. Yeah, and similar for like this Ethereum one, that's what we're getting now for the Tritium Milestone, right? Part of the milestone that is achieved now actually makes Ethereum functionality, makes reading from the Ethereum and writing to the Ethereum blockchain available to ICP smart contracts.
Very nice, I see. So chain fusion is kind of the chain key signatures as we knew them before, but also these sort of network integrations. So some way to read and write to Bitcoin easily, some way to read and write to Ethereum easily. And yes, I see. Sorry.
Exactly.
I see where you're going with
you got it
right now. So now we have this way to read and write to Ethereum a little bit more easily. And this is like one of the first things that is released today, actually, in this Tritium Milestone. Maybe you can tell us a bit about this RPC canister. How is this useful for us?
Right. So the Tritium Milestone is really like about three things. It is like the what you've mentioned, the EVM RPC calls, but it's also about the improvements on the ECDSA signatures, like threshold signing capabilities, and then it's like the first ERC20 twin on ICP, which is USDC, that Dom sort of as an Easter egg already mentioned yesterday in his video. And it's these three things. But indeed, let's talk about the EVM RPC calls first. So the idea here is that you can read from any EVM blockchain, and so far Ethereum, I guess Arbitrum, 4 others are supported. And so here, as an ICP smart contract, you can talk to another smart contract that then by itself calls out to a different RPC provider and gets the answers back via HTTP outcalls. So already those answers are trustworthy in the sense the calls are made by different nodes and then runs a consensus, because that RPC provider for sure did give that reply. It's not like a single faulty node maybe can modify the answer there. But on top of that, of course, you don't want to rely on a single RPC provider, but you want to make sure that all of them give you the same answer, so that they can sort of trick you into something. And so that means on top of that, consensus is run over those answers, and only if those answers are matching, then you get it back to the smart contract that actually wanted to talk to that EVM chain, Ethereum, Arbitrum, and whatnot.
So this is something that makes the developer experience a lot better by the sound of it.
Totally. As an ICP developer, of course, I could already use HTTP outcall. It's not something that wasn't possible before, because the protocol already offered in some sense the capabilities. But of course, if you do that, so you need to maintain API keys from all of those providers. Then you need to call out those providers. Then you need to compare the result. All of that shebang, right? And everybody who wants to do that needs to do it ever again. Of course, you could make a library or code somewhere, but then you also need to manage those keys. It's a lot of work that everybody would have to do. And so I guess at DFINITY we decided, let's just do that once and for all. Let's make the life of everybody easier, so people can just go and use it, and be a user of Chain Fusion and build cool stuff without having to deal with all these little details.
Nice. So it sounds like the developers will be quite happy. Will they have speed? So you mentioned also some protocol updates that sound pretty cool. Maybe you can go a bit more into that?
Yeah, we shaved off some of the latency for those protocols. Threshold assigning, it's a threshold protocol. So it's a protocol that's run between the nodes of the subnet. So they need to communicate with each other in order to produce that signature. So maybe a step back here. So what is a threshold signature? So you have a public key, and the signing key doesn't really exist, but it's shared amongst those nodes. And now, of course, they need to do some like shared computation in order to compute the signatures. They need to communicate with each other. They need to do some randomness, right? Because like the signature schemes in signing have some randomness. And so there's a lot of steps involved here. And then again, they need to be like run that through consensus and so on and so forth. We could talk for hours here about the cryptography, but I guess we'll spare you the details. Sorry. You love the kind of stuff, don't you? But anyway, the whole point is that like we improved the protocol there quite a bit. So it's like we managed to save one consensus round here, which is like about 2 seconds. Consensus is faster than that, but the end result is like something close to 2 seconds that we shaved the latency off.
Very nice. So the protocol geeks will be happy with better latency, higher throughput. Let's geek out for a second because we do love talking about this stuff. There's some debate on Twitter, I don't know if you've been following, about whether or not threshold signatures should be considered MPC. What's your opinion?
Oh, it's like the model of MPC, right? Like multi-party computation. Like by definition, anything threshold computation is like multi-party computation. So, of course, it's specialized. It's not like a generic kind of circuit. But actually, as you mentioned that, right? I mean, something I'm also excited a bit. It's beyond tritium. Of course, it's like Schnorr signatures and exactly. But the improvement we did actually for Schnorr even kicks in a much bigger time. So when Schnorr threshold Schnorr will come out, it will be even like way faster. And so that's actually why I'm very excited about that part of the tritium, because it will make Schnorr when it comes out in a few not too far future. Don't spoil the date now. Will be actually super cool.
Yeah, so that's cool. So like each milestone, or maybe not each milestone, but tritium at least sort of lays some of the groundwork for, okay, it improves the releases now, so it improves the protocol now, but these like improvements also carry forward to the next features that we are working on. That's nice. So the developers are happy, the protocol geeks are happy. What about the end users? Is there something in Tritium that keeps those happy as well?
Of course, like as we mentioned, like ckUSDC is live, right? So I can send you now like very quickly ckUSDC, right? If I had to do that like on Ethereum, like it would cost me a fortune in transaction fees. It would take forever. And no, like on OpenChat, I can just send it now on ICP, and it is bleeding fast. It gets the power of ICP. So let's send you some.
This was actually not not that this is planned or anything, but this was not part of the non-plan.
So I'll send you something here.
Thanks. This is one of the cool things about working here. It's like you get to play with all these toys when you build them.
Right. So here you go. And I'll send you $3, $1 for every year of ICP so far. Okay, so now I've just sent it.
Yeah.
And now you see it didn't really cost. It cost me like actually literally 1 cent. It is the only transaction fee that has done. And so you should have got it by now.
Yeah.
You're still logging in, I see. You were not prepared for this. But you see, like even logging in on Web3 and ICP is very fast release. It's just your fingerprint authenticator smiling nicely to the phone, and it's done. You get some dollars.
Cool. Actually, I don't know if we want to talk about this, but yesterday I was playing around with ckUSDC, and I sent a transaction from a centralized exchange to Oisy wallet, actually, this wallet on ICP, a browser wallet, passkeys, all sorts of fancy stuff, Threshold crypto, everything in there, NPC signatures, whatever you want to call them. But the transfer from the centralized exchange to my wallet cost me $8. And then I also sent some to people just testing around, also to you. And it cost me 1 cent to send. So, and like, it was much faster, and it is great. It's just super convenient. So yeah, as an end user as well, I'm also super pleased with this.
Next time we'll have dinner. We split the cost like via OpenChat, right?
Yeah. And so you mentioned OpenChat. Actually, now that we have, so we've covered a bit kind of what has been released in this milestone. There's the developer experience update with the RPC canister. There's the protocol updates. There's the end user stuff with the ckUSDC. What about the ecosystem? Like, what projects are using this now so far? What kind of traction have we seen? How does this benefit the ICP ecosystem?
I mean, obviously, I guess it's sort of implicit in the name, right? I mean, USDC is a stable coin, right? And so now I guess like a lot of people were saying, well, like there's no stable coin on ICP. Well, actually, there is. There's also Taller and Taller DAO that's just there. But I guess maybe dollar is like a natural stable because it's actually a stable coin, right? So now you can do DeFi much easier on ICP. You can like go into all these meme coins and like all of that.
These coins, whatever.
You do all of that kind of stuff, right? Because now you have a stable coin, and since the transaction fees are so low, right, you could just play with it, like game it, have all that DeFi fun very easily now on ICP as well. Whereas before maybe it wasn't, but it still was a ton of fun, and I guess I also did some NFTs and meme coins myself, but I think now actually most people want to have a stable coin. Now it's available. And some of the DEXs and so on and so forth have it too. So, guys, let's have fun.
Nice. So, I think you mentioned OpenChat, the DEXs, it's in some of the wallets. We've been sending it around, swapping, changing, minting. Looks cool. So, it's clear why this is nice for the ICP ecosystem, but this is kind of our first Ethereum milestone. So, I think it's interesting also to think about how can something like Tritium benefit the Ethereum ecosystem generally.
Yeah, I mean, like ICP has like a lot of capabilities that like are hard to find on other blockchains, right? Like smart contracts being able to make HTTP outcalls, like just every smart contract has a URL. You only need a browser to interact with that. So like you could do front ends that like interact with like an Ethereum smart contract. If you want to do like a DEX or like a stable coin, you need price oracles. Just use HTTP outcalls. Or actually, there's like a canister on ICP already that does that for you. So you just can query that for all kind of prices. So like all these features on ICP, you can have like a smart contract that holds whatever Bitcoin ICP, and then reading events on Ethereum, and then depending on that, selling, buying, and whatnot. Or you can monitor your Ethereum smart contract and charge it up with some more ETH if it runs out. I mean, I think the possibilities are really endless. And I mean, there's a famous chart about the Ethereum ecosystem with all these little tiles. I think any one of those tiles you can also build on ICP if you want to, right? And more than that. So it's like
I think
a lot of stuff to be done here.
Like one of the important things about a lot of the building blocks in the Ethereum ecosystem is that they're centralized, actually. I mean, so a lot of the services come from AWS. I mean, a lot of the front ends are hosted in centralized places. A lot of the services are either like expensive or slow or like not really directly accessible by developers. So like you mentioned the HTTPS outcalls, which I like to call web fusion. I'm trying to get that in there. But it means like that...
Let me update the roadmap.
Yeah. But it means that a developer can just in one line of code essentially like get their own price feeds or define their own like weather or whatever, this kind of stuff.
Yeah, but build your sequencer on ICP, right? Boom, you have like a decentralized sequencer. It's like very easy.
And these are things that are on like the kind of multi-year roadmap of many other projects. So
yeah,
I mean, I think there's like really a lot to explore. I'm super excited about it. One thing that you mentioned, it's a slight tangent, 30-second tangent, if you don't mind, but I think everyone would be super happy to hear about it. And it's about this, I mean, it goes a bit in the Web Fusion direction, but it's about chain key signatures and verifiability. So is there something that you can say about this and how we sort of, like, why are we able to, like, host web content, like serve web content from canisters? Why is it that, like, other blockchains cannot do this? What is special?
Right. So this is like the internet computer having like a single public key. So that's all the internet computer's public key. And like any message that the internet computer sends out is actually signed with that public key. So like on Ethereum, if I really want to make sure that I get the result from a smart contract, that's the correct smart contract, I sort of either have to trust like the the verifying node, or I have to download the whole state myself and then just run everything and do that. On the intercomputer protocol, like with chain key signatures, all I need to know is this public key. I query a smart contract, get a single message back together with like a chain key signature, and now I know, okay, that actually comes from the intercomputer. So it's actually very easy. I can, like my smart watch, if I had one here, I could verify, like, okay, this is like actually what got produced on the intercomputer. It's like a like a verifiable message. It's decentralized, so all of that. So it's very easy to get trustworthy results.
And I think like this is one of the internet computer arguments as old as time, but I think there's a lot of new people coming into the ecosystem that maybe don't see this, because it was one of the first big innovations of the internet computer. It was live at the launch. And so for me, this is like one of the coolest things in the whole industry, never mind just about the internet computer. So it's something that I try to like really reiterate, that like this is the thing that allows sort of compute on the internet, really. Like,
yeah, totally. And also in the context of we just discussed chain fusion, right? If I have a smart contract on another chain, how do I know that like what the message I'm getting is like, like comes from an ICP smart contract? And because like for like on ICP, we have done integration with Bitcoin. So if I see a Bitcoin transaction, the ICP network guarantees me that like as a smart contract that actually comes from the Bitcoin network. But on the other chains, they don't do this like integration, this direct integration. So the way to actually read information from ICPs, like via chain key signature, right? So these messages are signed, and then as a smart contract, like on most chains, actually I can like have an API to verify signatures, and to just can very easily verify those signatures and be assured that like what I'm getting back is actually was actually computed by a smart contract.
This is great, and I think like it's we talk about like, I mean, a lot of the narratives in the industry are around oracles or around like DA or around, like just a lot of conversations around modularity. So there's like different people building different building blocks. And so for me, this is like one of those things that really ties it all together. So I really love that you took you took my bait and allowed me to go on this little tangent. But
but I think that's actually essential about chain fusion. It's all about this modularity and make the different chains, different pieces to work together. And chain fusion is all about enabling even different chains to talk to each other, right? I mean, we are ICP, so it's like, let's build stuff with all the best things from all over the place.
So, Jan, we've talked about chain fusion, we've talked about Tritium, we've talked about pleasing, like making a better developer experience, we've talked about protocol updates, we've talked about end user experience, both within the ICP ecosystem, and then how we can bring all those superpowers to the Ethereum world. I see that an old colleague of yours has just walked in, and I'm sure you need to get back to work. So I'll let you go, but like, thank you so much for taking the time to just explain some stuff to me and generally everyone who's interested to listen. Thanks very much.
Thanks a ton, Aisling, and I'm sure we'll see each other down here like more often.
Yeah,
and like have fun on that nice little setup here.
Thank you very much. Bye.